Hello class. In this video we're going to be looking at Chapter 6, Repetition or Looping Structures. And as in Chapter 5, this is an instructor PowerPoint and you're still expected to look through the publisher PowerPoint to see if there's any pertinent information that you need to add to your notes. Do be continuing to update your OneNote notes so that you have good information contained all in one place. When it comes time to review for the final, it'll be a lot easier to review a OneNote notebook than the entire textbook chapters that we complete, because we won't complete all of them. But for today, we're talking about looping or repeating structures. So when we're programming, we oftentimes need to have pieces of code or logical chunks of code repeated so that we can do something until a certain condition is true, or until we've done it a certain number of times, or depending on what our situation might be. So repetition structures or looping structures allow us to do those kinds of things in our code without repeating our code. We can think of an assembly line. If we have a looping structure in place, we can check to see if there's another car to paint. If there is a car to paint, we'll go ahead and tape it off. Move the car to the paint area, paint the car, and then move it to the drying area. Then we could go check to see if there's another car that's ready to paint. If there is, we would repeat this same process. That would be our loop body, pretty much that those steps that we take to actually paint the car. So we would continue this looping structure until we were done painting all of the cars, or out of time. We might have a more complex condition than that, but until we were out of cars. Now this loop is considered top controlled because we checked to see if there was a car to paint before we started painting a car, which seems like a good thing to do, but sometimes we don't need to do that. Now, a top-controlled loop is pretty standard, and an assembly line gives us a really good example of a looping structure in practice. Working with a while statement is one of the common structures that we'll use is a looping structure. And a while statement is exactly the same as an if statement, except that we replace the keyword if with the keyword while. So this would be a single selection if statement. We have the keyword while then followed by our conditional expression enclosed with parentheses, and that would be our condition. And so while that condition is true, we're going to execute the lines of code in our while statement body. When we're done executing the lines of code in the while statement body is indicated by the closing curly brace. Execution will return to the while statement to reevaluate that condition. If the condition is still true, the lines of code in the while statement body will execute again. We'll get to the closing curly brace. Control will return back to the while statement to reevaluate that expression. When the expression evaluates to false, control will continue at the line of code following our closing curly brace. So we just have this little inner moment here where we can do some pieces of code over and over until we're done, and then we'll continue on. Now, just like an if statement, we can have our while statement without curly braces if our while statement body is only one line long. And of course, we could put it all on one line of code. Now the conditional is exactly the same as the conditional expression in an if statement. So just like an if statement, we're going to evaluate the condition. However, with our looping structures, we may be executing our loop body if this condition is true. We may be executing it as if the condition is false. It's kind of up to us and how we code it. We can control that ourselves in the code. So just like in any other conditional expression, we want our conditional expression to result in a Boolean value, either true or false. We can use the same relational operators that we use to build our conditional expression for if statements because they are exactly the same. Now our test condition, just like an if statement, must have both sides, A equal to B. We have to have our left operand and our right operand and our evaluation condition in between. Our operands could be variables. The operands could be literals, like while answer equals 42. If we're working with a looping structure in a while situation, we can use the equality operator to continue executing some sort of code while a given condition is true. So in this case, we have our red light, and instead of just doing a simple if statement to see if the light is red, we've got a more involved process here where we're going to check our stoplight. While the light is red, we're going to stop. Now, in that process, we're going to check that light again, see if it's still red. Yes, we're going to stop. Check that light again. Is it still red? Yes, we're going to stop. And we're going to keep doing that process until the state of that light changes to green, and then we would stop this process when our condition changed. So this is really a state-controlled loop. The state of the traffic light is going to control whether we continue or not. And we know that we sometimes get stuck behind people who aren't checking that light very often, and it could be a big mess. Now, when we're working with a looping statement, we want to think about what order we're doing these operations in. So in our example, we're going to check the stoplight. If it's red, continue stopping. Check the stoplight. If it's red, continue stopping. So again, when the state or color of our light changes, we'll exit our loop. So the state of this stoplight is what's controlling our looping process. Now, whenever we're working with a loop control variable, like the stoplight, or many others that we'll look at here in a second as examples, we always have three things that have to happen for our loop control variable, whatever information is controlling our loop. First of all, that variable has to be initialized. And in our example of our stoplight, we check the light to initialize our light status, and that gives us the color of our light. Then we have to test that variable. Is it red? Is what we tested for in our case. And then through some external process in this situation, that stoplight value can be updated and the value can change to green. That's why we're going to keep checking it. So we have to have all three of these things happening with the variable that's controlling our loop structure. It has to be initialized, we have to test it, and it has to be updated as part of our looping. You'll see what I mean. Now, we can continue to use inequality operators just like we do with if statements, and sometimes they're exactly what we need. For example, we might have a while loop that says, while the size of the window is less than the size of the display, reduce the size of the display by 10 pixels. And this would be something we would run if our window size were resized by the user. We might have another process that says, while the number of names input by the user is less than 10, prompt them for another name, because we need 10. We could have another option that's, while the number of tickets is greater than 5, we would continue to ride rides at the fair. So all of these things are things that we do in real life all of the time when we're deciding what action we're going to take next. Now, the while statement kind of summarized here. Our keyword is while. The conditional expression is enclosed within parentheses. Our loop statement body is enclosed by curly braces, and there is no semicolon. Now, we can have just a one statement while loop without curly braces, and we can put everything all on one line if we just have that one statement body. Now, we mentioned earlier the top-controlled loop. A top-controlled loop is a type of loop where the condition of our loop is tested at the top. So we'll execute the while statement body if that condition is true. For example, we might set up a while loop that says, as a test, do I have chips If I do, I'll pick one up, add some dip, eat that chip. Then I'll do check for another. My check for another will result in some sort of information that lets me answer the question again, do I have more chips? If I do, I can pick one up, add some dip, eat that chips, and check for another. So I'm going to continue executing this series of events, this sequence of code, until I run out of chips. The opposite of a top controlled loop is a bottom controlled loop. Surprise, huh? And this is where we test the condition at the bottom of the loop. So we're going to execute the body of the loop, the while body. Then at the end, check to see if the condition is true. So with C# we implement this with a do while structure. So we would start out with the keyword do, then the body of our loop, and then we would close our loop with our while condition. So in this example, we're just going to sit down, pick up a chip, add some dip, eat that chip, check for another, and then see, are there more chips at the very end of our loop? If there are, we'll pick one up, add some dip, eat that chip, and check for another. So looking at our loop cycle here, it doesn't look extremely different to have this bottom controlled loop. But some important things to think about. With a bottom controlled loop, the body of our loop is always going to be executed at least one time. So we have to make sure that the situation is correct for that it can execute that one time. With a top controlled loop, we may not ever execute our loop if things are not properly initialized for our loop to begin. So before we get into some code here, let's look at the syntax again of that do while statement. It is a little different. It starts with the keyword do and ends with the keyword while, so it's a combination. The statement body is enclosed within curly braces, and our conditional expression is enclosed within parentheses, just like always. But this one is a little different. There is a semicolon at the end of that conditional expression to close out that do while statement. Because it is kind of an unusual syntax, there is no way we can compress it without our curly braces, and we can't put it on one line. Yay. Okay, so here's a loop. Let's look at some examples. In this example, we have a count controlled loop, and we're going to set it up with two variables, one called count, this is going to be our limit variable, and one called iteration, and we're setting count to 5 and iteration to 0. In this while loop, we're going to execute while our iteration variable is less than our count variable. Within our loop body, we're going to write out a statement. This is iteration number parameter, and then replacement value, our iteration variable. And then we're going to add to our iteration variable. So we should expect some output like this if we were to run this program. Let's try it. I'm going to open Visual Studio. And I'm going to create a new project. And I'm going to name this looping. Now in my looping project here solution, I'm probably going to add more than one project. So this very first one, instead of program.cs, I'm going to rename that and make it be just while loop. Now in our while loop program, we're going to do the exact same thing we were just looking at. So we have two integer variables. And we're going to create a while loop. Now our condition is while our iteration variable is less than our count variable, we want to do some things. And what we want to do is a console.writeLine. And we want to output, this is iteration number. And then we're going to use our iteration variable to replace that parameter. Now, if we ran our program like this, we would never get done, right? Because we would be in an infinite loop. We would never satisfy that condition. When we're programming, we always have to be super careful of that because infinite loops can cause some trouble. Visual Studio knows about infinite loops, and so they do a really good job of auto-saving our code for us, but it's still always a really good idea to do a save all often when you're testing programs with looping structures, especially when you're changing your condition. On REPL, I've managed to break it, so I was going to give you guys an infinite loop to correct, but it doesn't seem to like that at all. Now we're going to update our iteration variable. So looking at our program, iteration is our loop control variable. It's the one that we're going to be kind of using, messing with. So we're going to start out initializing it. And then here in our while loop, we're going to be testing the value of that loop control variable to make sure it hasn't gotten up to the value of our count so that we should stop our loop. And then within our loop body, we're going to be updating that loop control variable. So let's run this code. I'm going to use Control F5 so that my console window will stay open. And there's my output. This is iteration number 0, 1, 2, 3, and 4. So not too complex of code. We can label some things and make sure that we're on board here. Here's the end of our main and the end of our class and the end of our solution. And then, of course, if you wanted to run this code in REPL, you could just copy from the class to the end of the class because REPL doesn't like that namespace or that solution part. Okay, so that's our first while loop. This is a count-controlled loop because we're using our iterator as a count. Now in this loop, if you notice, we started out testing, then we wrote our output and incremented our loop control variable. Then we tested it, wrote it out, incremented it. So that's what we were doing there. Now let's update our program like this example and copy our while statement. And it says there's something wrong. Let's see if we can tell what's wrong. Not that one. This one. So I want to copy my while loop, and I've conveniently labeled that ending or closing curly brace. So I'll select that and copy my entire while loop and then paste it. Now in this second while loop, I want to change my WriteLine statement to say something like second iteration number. Shouldn't cause us any problems, right? So let's run it. I'm only getting the first while loop as output. So let's take a look at our code and see if we can figure out what the problem is. In your next chapter, in chapter 12, you're going to be looking at a lot of the capabilities of the debugger, and it's a really important tool. And to be an excellent programmer, you need to take advantage of the tool and really get used to how it works. Let's take a little preview here and set up a breakpoint. We've done it before. We did it very quickly, but now we have a mission. We want to use that debugger to debug our problem. We didn't get any output from our second loop. So I'm going to set up the debugger with a breakpoint. And what I want to do is break here at this while statement. So the easiest way to set a breakpoint is to come over here into this gray bar area and just click on the line of code that you want to set the breakpoint on. Now you could also right click on that line of code and choose breakpoint, add. Mine says delete because I already have one, but you could add one, or you could use the debug menu to add a breakpoint. And with the debug menu, you can toggle them on and off so that you can keep your breakpoints active if you have some really key locations in your program that you need to be debugging. Now, I cannot use Control F5 to run this program and make my console stay active with the debugger. If I use Control F5, my program is not going to let me debug it. It's like one or the other. It's a thing. So I don't really want to start without debugging using my Control F5, but I do kind of want to be able to see my output at the end. So I think I'm going to go ahead and add in, after my second while loop, my console.read key statement to make that console screen hang so that I can just run this program in the regular manner and use the debugger. So I think I'm all set. I did have to do a little setup to set up this breakpoint to make sure that I could debug my program, but it's totally worth it. So now I'm going to start my program, and I see that console screen flash, and then it comes back to Visual Studio. The debugger has the line of code that it's ready to execute highlighted in yellow, and it has this yellow arrow pointing at the line of code. That means that the next line of code that's going to be run by the system is this line of code. Now, an important place for us to look is down here at our locals screen. You see we have all of our local variables displaying on this screen. So we have our count, that's value right now is 5, and it's an integer. And we have our iteration variable, whose value is 0, and it's an integer also. On the watch screen, we could add additional pieces of information to keep track of from the debugger. I'll let you look at that information in that next chapter. But for now, this local screen is enough for us. And we know that this first loop executes. So let's watch it execute. I'm going to use this command here, step into, and what that's going to do is run the current line of code. So it will execute the test condition of this while statement to decide if the while loop body should be executed or not. Now we see that it's sitting at the opening curly brace, prepared to execute the while statement body. The condition was true. We're going to execute this line of code that writes a line to our console. We're going to add to our iteration variable. Now we are sitting at the end of our loop, ready to test that loop condition again. Notice that in your locals screen, the iterations variable's value has changed to 1 because we just added to it. Now I'm going to use that action again, step into, go back to my conditional test. My conditions should still be true. Execute my right line, add to my iteration. Now you see the variable value change down in the local screen. Execute the test again, write the line, add to the iterator one more time. Now our iteration is at 4. One more time. Now finally, when we add to our iteration variable, it should be at the value of 5. So that should end our loop. And we'll see that control now branches to the statement after the closing curly brace of our current while loop. So now we're at our second while loop. Look at our variable values. Is this while loop going to execute? We've said that our while loop should only execute if the iteration is less than the count. And right now they're both set to 5. So no, this while loop is not going to execute. Let's double check. step into, and it just jumps right over it, goes to our console.read key statement, and then I can bring up the console and see indeed we only got output from our first execution of that while loop. Well, now we know what to do to fix that problem, because using the debugger, we saw that the issue is that we need to reinitialize our iteration variable before our next loop. So I can set it back to 0. I'll turn off my breakpoint. And now when I run, I can do a control F5, but I don't need to because I have my console.read key. So I should see output from my first loop and output from my second loop. So again, the loop control variable for any loop has to be initialized, tested, and updated. And notice that if that loop control variable is going to be used again, it may need to be reinitialized. So that's a great sample for us looking at Visual Studio. Now we can also do a bottom controlled loop, a do while. And with this kind of loop, we actually are going to switch things up a little bit. We're going to use our count and our iterate variables again, but this time we'll go straight into our do loop and write out the first iteration's value. Then we'll add to our iterate variable, and then we'll check to see if we should execute that loop again. So looking at the way this loop control is working, we actually write out our message, then increment. So we do our loop body first, then we test our value. If our value still comes out with a true, then we write and increment again. So let's set this one up in Visual Studio. What I'm going to do is find the right project first. In our solution, for Visual Studio here, if you look at your Solution Explorer, I'd like to add another project to the solution, and you've seen them do it in the textbook. Let's practice a little bit. I want to make sure that I have the solution itself, the top level of my structure selected, and then I can right-click and say that I want to add a new project. Now, of course, there are other places within the menu system that you could do that, but we always need to have our solution selected before we add our new project. Now, this new project is going to be, again, a console app, and I'm going to call this one Do While. In our Do While, then, let's set up our variables. And so I want my count to be 5. And then go into our do loop. So in our do loop, we want to do a right line here. Anthony's got his work going. And in our right line, we're going to write out do while iteration. And then our replacement will be our iteration variable. Then we'll update our iteration variable. And then finally, at our closing curly brace, we'll add our while condition. Our condition is going to be while our iteration is less than our count. Same as it was before, right? I'm missing a semicolon there. So I'm going to control F5 to run this. And oops, look at that. I'm getting output from my previous project. In Visual Studio, we can right-click on the project that we're working on and set a startup project so that that project will automatically run. And then control F5 again and see our new do while output. So same thing. 0 through 4 are the numbers output. That's 5 of them. So we started with 0, right? So our do while loop has executed in the same way. Now, just like we did before, let's copy that and paste it to run our loop again. And I will change this to second iteration so we can see those messages. Let's run it. Well, that's different, isn't it? Last time, our second loop just didn't execute at all because we hadn't properly reinitialized our iteration variable. In this example, we haven't properly initialized it. And look, we got one output. It tells us that that variable is equal to 5 here on this, inside this do while loop. So that shows us that that loop was executed before our condition was checked. And as soon as our condition was checked, that do while loop ended because our iteration was already too high. So with our top controlled while loop, it kept, since our initialization and our variable was not correct, it kept us from executing our loop at all. With this bottom controlled loop, we did get one output from our loop. So notice how debugging these problems could be a little bit different depending on how things are set up in the code. We could go ahead and, just like before, reinitialize our iteration variable so that it's back to 0. And now when we run, we should get output from both of our loops. All right. So top controlled, bottom controlled. Besides the controlling aspect of our loop, we have different kinds of loops to meet different purposes. So a lot of our loops will be count or counter controlled, where we're saying the same thing as in our example. We have this certain number of times that we would like to do something. Then often we'll have state-controlled loops that would use Boolean variables to indicate a true or false state, like stop or go. Or is it the example of our stoplight, maybe 3 states? So a state-controlled loop often uses a Boolean, but if our traffic light would need to use something a little bit different, wouldn't it? And then we can have sentinel-controlled loops where we ask the user to continue entering and to enter some sort of special, unexpected number or value to stop the loop. So we've seen all of those different kinds, and we'll definitely have all those different kinds set up in REPL. So get some more practice on that REPL course for this section. I do have a completely separate course for the looping structures versus the if statements so that they won't be quite so long. Now, another looping structure that's quite powerful and used very often in C# is the for loop. And the for loop takes those 3 steps that we have to always be concerned about with our loop control variable and compresses them into one line of code. So in the for statement, we start out the for statement with parentheses. And inside the parentheses, we have 3 phases, 3 steps of this for loop. The first step is the initialization step. And in the initialization step, we say the variable that's going to control this loop. So for our example, we want to use our iteration variable. We'll go ahead and let this for loop declare that variable or allocate it in memory. So we're going to put the int keyword in front of it. Now we close out that phase of our for loop with a semicolon. And if we didn't have this initialization phase at all, we would just have that semicolon as a placeholder. Next, we have the test condition that affects this loop. So in our example, our test condition is that we want to loop while our iteration is less than our count variable. And that test condition phase is also ended with the parenthesis. The third part of our for loop syntax then is how do we want to update after each execution of our loop body. And in our case, we want to add 1 to our iteration variable every time that loop body executes. Notice that our loop body became smaller because all we need to do in our loop body is write out our message, because all of that loop control information, like adding to our iteration variable, is taken care of by the for loop structure itself. So let's run that one in Visual Studio. Sorry, too many projects open. Here we go. I'd like to create another project for this. So again, I'm going to click on my solution, right click and choose Add New Project. And I want this one to be my for loop. And in my for loop, I'm going to have basically the same as we had before. But I don't need to declare my iteration variable because I'm going to declare it as part of my for loop. So I'm going to say my iteration is an integer, and I want it initialized to 0 to start this loop. I want this loop to execute while my iteration variable is less than the count variable. And each time this loop executes, I want to increase iteration. For loop iteration number, and then we'll put in our parameter and replace our parameter with our iteration variable. All right, that should be our whole loop, because again, our for loop is going to take care of all of those other housekeeping chores that we were having to do ourselves with the while loop. So let's run it. Oops, I did it again, right? What do I need to do? I need to make this one be the active project, my startup project. Now I can control F5 and I'll see my for loop output. You can tell that's why I made those messages a little bit different. Now my for loop iteration looks like it's working great. Everything's good to go. Now when we are working with our for loop, our variable here, our iteration variable, becomes local to that for loop. Here's an example. If I tried to access the iteration variable outside of that for loop, I'd get a syntax error. That iteration variable is only available for use within that for loop. It's local to the for loop. Now I can change that if I need to by declaring the iteration variable as I did earlier for the while statements. I can still use that iteration variable to control our for loop, because I can say set the iteration equal to 0 to start, run while it's less than count, and add to the iteration. And in that case then I'll be able to access that variable outside of this loop. Now I could also, in my code here, set iteration equal to 0 and completely eliminate this step of the for loop and just leave the semicolon there without any code, and then that would do the same thing in this example. We can nest loops just the same way as we can nest if statements. We can put if statements with inside while loops and for loops inside while loops and while loops inside for loops, and there is no limit to what we can do, because that's the reason that we have C# as a programming language, so that we have those capabilities to do anything that we need to do, any place that we need to do it. Now this example shows a nested for loop. Let's run it ourselves. Doesn't want to come back over here. So again, I want to create another project. See that I didn't want to come over here because I was fighting with the wrong one. There it is. So let's create one more project. And this will be nested. And again, we're just going to do a nested for loop. And you should try some practice programs whenever you get a chance, using while loops and for loops and anything that you can think of. Now, since I have a terrible time remembering, I'm going to right click and set this as the startup project before I put the code in. Now in my nested for, I wanted to start out with a for loop And I'm going to do a row and column kind of structure. So I'm going to start out with a variable named row, and I'm going to initialize it to 0. And I'm going to run this loop while row is less than 5. And I want to increment the value of row each time this loop executes. Within this loop, the first thing I'm going to do is a console.write statement. And notice I'm going to do a write. Let's try a write line first. And I want to write out what row this is. So I'll output that row variable. Now I want to go into an inner for loop, and this one is going to be based on a variable named call, short for column. And I'm going to start out again with that variable equal to 0 and run while that variable is less than 5. And I'm going to increment it each time I execute the for loop body. Now inside this for loop, I want to do another console.writeLine. And this time I want to output, I'm going to put a couple spaces here so it'll be indented. And I want to output the column number. Now we hadn't been labeling our closing curly braces, but you can see how these things can get pretty messy and why some people would like the curly braces being color-coded like this. And of course, if you didn't watch that video about how to get that software, do go ahead and watch that. It was part of our introductory series. Now I have an inner for loop that works with this variable named column and an outer for loop that works with this variable named row. So let's run my program. Well, that doesn't really look like rows and columns, does it? But I do have some interesting things. I have row 0 and then column 0, 1, 2, 3, 4. Row 1, column 0, 1, 2, 3, 4. So notice how every time I execute that outer loop, my inner loop executes to completion. And my outer loop gets changed a whole nother time of my inner loop. So I can do a lot of really powerful things because of those kinds of logic structures that I have available. Well, anyways, that doesn't really look like columns. So I think I want to change this a little bit to make it just do console.write here on my columns. And I've already got some space there. So it should just give me my row number as output and then each of the columns for that row so that it looks more like a row column kind of structure. So I'm going to run that again. Well, that's a little better, but I've got row 0 up at the top, but then all my columns look right, but then my next row numbers are not in a very good place. So there's a few ways I could fix that. Let's do it after our inner for loop. I'm going to go ahead and write at that point a new line character out. So we just got done with all those columns. So let's go to a new line before we continue on. Now let's see how that works. Oh, that looks better. So now we have row 0 in each of its columns, and then row 1 in each of its columns, and then etc. So looks good. Now if we wanted our columns to all show up on the same line as our row, we could make that be a write statement instead of a write line. And then we have our rows and columns. So depending on how you wanted to format that. But that just really illustrates for us this inner and this outer for loop and how we can do all sorts of things with that kind of work. When we're working with for loops and while loops, our conditional statement can be just the same as the conditional expression in an if statement. There is absolutely no difference. We're going to use the same logical operators to create compound expressions. We have the short circuit operators as well as our logical operators. We have the same order of operations that applies to determine if a conditional expression is going to result in a true or a false value. So in summary, repeating code lets us set up an algorithm and execute it over and over until a condition is true or a state is changed. And the decision making that we do with our conditional expressions is really the heart of programming. And not only does it control our if statement logic, but it controls the execution of our repetition structures based on variable data and conditions. So really important stuff for us. Repetition structures in C# are the while, do while, and the for. And you want to continue creating practice programs to work with different data types, values, and conditions. Now, before we go, I wanted to show you some things about the console, because the console class is something that we've been working with since the very beginning, but we haven't done really a lot except write lines or read from it. So let's look at what else we can do. Whenever you were using the IntelliSense editor, after we type a keyword or a class name like the class name console, once we type the dot, the IntelliSense editor automatically gives us a drop-down list of all of the available methods and properties for that class. So looking at our console, we could change the title. Let's try that. So let's change it to I'm assuming a string. Because it's a property, we know we can set it equal to some value. That's what we do with our properties, our getters and setters. So let's set this to Renee's console. And now I'm going to do a Control F5 to run this. Oh yeah, there it is. So now it says Renee's console instead of whatever awesome message it had before. Let's try some other things. Can we customize it a little bit more? We could set the size and the position and all of those kinds of things if we wanted to. Lots of different things that we could do. Oh, it looks like there's some color items. So let's try some color. Looks like I have foreground color and background color. There's background color. So I want to set my background color. I'm going to set it to a color. A console color, looks like what I have to use, type of object. And the color that I want, let's see, this is going to be my background color. Oh, I want to do that, what do we want to do, like all matrixy? Do we want to, let's make it, I kind of want to leave it black, but then that won't really show much. So let's try green, and we'll make the foreground color our font. Let's make it black, sort of matrixy, but not super. Now let's see how that works. I'm going to Control F5 and see. Oh, it did some kind of weird things, didn't it? It gave me sort of a background, but not exactly what I would like. But it is sort of doing it. So there was that one, I saw that reset. Let's see if we need to do something like that. And I went past it and it wasn't what I wanted. So I'm going to go back and look a little bit more and see what that was. There was like clear. What's reset color do? Sets the foreground and background to their defaults. I don't know why it won't let us change that. So I'll let you fiddle with that. It may just not be a capability of the console. We could go ahead and make it beep if we wanted to. Now that's a method, right? So with methods, we have to put the opening, closing parentheses to say, nope, I'm not sending you any sort of information. Ooh, it beeped. It scared me. It scared you. Okay. So we made our console do some things. So always some fun stuff we can go look at when we're testing and trying some different things. So always be working with practice programs and trying to expand your knowledge, because you know that it's kind of up to you, right, in the end. So thank you so much. I hope you enjoy this chapter. It is pretty fun.